Brilliant. Hello, everyone. My name is Ben McCarthy. I see some people kind of joining at the moment. But yeah, welcome to the Immersive Labs webinar. And thank you everyone for the time to come and have a look at what we've been creating recently, which is very exciting. So, of course, yeah, you have to fumble the slides at the beginning. So we're going to talk about this recent series that we just released on our platform, Intro to Static Code Analysis for Reverse Engineering. And just a quick background about myself. So my name is Ben McCarthy. I'm one of the lead content engineers here at Immersive Labs. I have been currently an employee for coming up to 3 years now, which is so almost a veteran at Immersive, which is great. But where my love lies within cybersecurity is basically reverse engineering, malware analysis, binary exploitation, and that side of things. So I was very excited to get the go ahead to put this series together, basically. So we're going to discuss a little bit about what the series is, the different aspects of the series, and then kind of where we're going to go with the next iteration of the sort of labs that we're going to be releasing. Awesome, but a little background about Immersive Labs first, just for everyone who's not not been on the platform, not seen it. We believe here at Immersive Labs, cybersecurity is a human challenge. We're all about upskilling and ensuring that your staff are prepared for all the latest cybersecurity threats, and we do this through a number of different things. That is by releasing threat intelligence labs within 24 hours of them hitting the news, so you can gain full practical skills on messing around with the latest pieces of malware, understanding the latest sort of CVEs, or you can upskill on general sort of cybersecurity aspects. So you've got if we're going into the reconnaissance phase of attacking, we've got the how to use Nmap, for example, all the way over to our sort of defensive, like Splunk log analysis, Sysmon, and we do progress into sort of the more difficult aspects of cybersecurity as well. So the point is that we believe that every employee needs to be ready for these sort of cybersecurity threats, and you can use the platform to gain those practical skills in order to be ready for these threats. So there's different aspects to the platform. So we do this thing called equipping, exercising, and evidencing. I call them the 3 E's. So firstly, we've got equipping. Now, these are the things I'm going to talk about the most because this is what our series covers here, is our coach and demonstrate labs. So our coach labs are all about guiding the user through basically a practical exercise. It's quite hands-on. It's all hands-on in our platform, but it's very much kind of, this is what we want you to be doing at a sort of step-by-step basis. And then we get onto the demonstrate, where we're saying, right, you've done all these coach labs related to a specific subject. Now demonstrate that you've understood this by giving completing a lab on something with very little information. And these are the 2 sort of lab types that we're gonna be covering in this series here. We also move on to sort of exercising as well, and that with reverse engineering there will be sort of these challenge labs released later on, and what they are is effectively, you can think of it almost like a CTF, where you have absolutely no information related to the lab or what you're doing, and it's just very much go in, mess about, use the techniques that you've learned about in our coach and demonstrate labs to really challenge yourself and see what you can do, really. And then we've got our simulate labs as well, and that is sort of our crisis simulation aspect, where we're taking tabletop exercises, we're really changing it and making it a more dynamic and online experience, which is absolutely brilliant. And we've also got evidencing. So for all the managers out there, you can gain sort of you can track and understand where your skills lie within your team. you can if they do a reverse engineering lab, you can gain full visibility. How long did it take someone to complete, and all this sort of very useful information from an evidencing perspective. But let's talk a little bit about the static code analysis for reverse engineering. So the reason we decided to actually start creating these labs in this lab series was because we were releasing quite a lot of sort of malware analysis threat intelligence labs. But what we realized is that we didn't really go over the techniques to bring someone into reverse engineering explicitly. So the issue with reverse engineering is that there is a lot that you need to know. It's a large subject. You need to know, especially with static code analysis, you need to know how a computer works, and then not only sort of how a computer works, but then all the different types of operating systems. For example, how does memory work? Then you have to move on to understanding assembly language, and then finally, once you understand these different aspects, you can then move on to beginning the techniques of analyzing malware or analyzing binaries for binary exploitation. So, the whole point of this series is to introduce those beginning aspects of reverse engineering. So I'll take you through some of the labs that we discuss about, what a portable executable is, for example, which is the native executable for the Windows operating system. Or, we'll go over the ELF executable structure. We'll go into what is 32-bit architecture and what is 64-bit architecture, and how do they differ, and then once we've done that, we can then start to look at which tools are used to understand which binary you're looking at, because there can be a whole host of different binaries and different ways that malware analysts and malware authors create their binaries. So why is it relevant? I would say it's incredibly relevant, especially today with malware being such a threat to organizations. You'll need to understand how a computer works to understand how and what a piece of malware is actually doing. So it's very beneficial for your defensive teams, your incident responders, some of your threat hunters, and then obviously your malware analysts. And on the other side of the coin, to malware analysis, we've also got binary exploitation. So it's also, this aspect is very relevant for that, because you need to understand what memory is. You need to understand what these binaries are, and how they're made up in order to run on the operating system, so that you can then understand how to break them and how to start changing their behavior, so that you can start executing malicious code, for example. So that's the whole point of what this series is to kind of give you an introduction into how to approach something from a binary exploitation aspect and a malware analysis aspect. And then later on in the later series that we end up releasing, we'll be going down into specific routes of things that malware authors do, and then also binary exploitation routes as well. Awesome. So yeah. So we released 3 series, sort of lab series underneath this overarching introduction to static code reverse engineering. Now, for everyone who doesn't know what static code reverse engineering is, this is where you analyze a binary or a file without actually running it. So the whole point is that it is completely static. You are not executing any portion of the file, and in this case, they're all binaries. Yeah, you do this because it kind of gives you it's a lot safer to analyze something when you're not actually running the code that's incorporated inside the binary. It's called dynamic code analysis if you if you're actually running it and attaching a debugger and then seeing what it does in real time. So that's why it's called static code analysis, because you're opening up these binaries up into things called disassemblers, which I'll take you through in a little while, and then just reading the code from when you're not actually executing it. So it's, like I said before, it's quite a complex aspect of cybersecurity, but it's really rewarding once you start getting your head down into it. So the first series that we released underneath this intro to static code analysis is computer architecture. So before before we want you to start messing around with assembly and writing it as well as reverse engineering it, we want you to understand the different aspects of computers. So that is what is the Windows operating system? What is the Linux operating system? How does a program go from the user mode, for example, to the kernel mode? All of these things are important for you to understand when you're progressing through your sort of reverse engineering career. Also, how does memory work? What is the stack? What is the heap? Both of these memory sort of aspects of the operating system are really important for you to understand. What is it that actually gets placed on the stack, and how is the stack manipulated? And what is it that gets placed on the heap, and how is the heap manipulated? Now, understanding those two pieces of memory and understanding how they're structured can really help you with your sort of binary exploitation. And you may have heard terms such as stack overflow and heap overflow, and these are two sort of binary exploitation techniques. And these are things that we will be releasing later on in our series of reverse engineering. But for now, we want you to understand what is it that actually the computer does in order to maintain that, and so that you can understand what it actually looks like. Because once you understand what it looks like, of course, then you can understand how to start to break it. Then once you've sort of completed the computer architectures labs, we move on to assembly language. Now, the way that we broke it down was we've initially gone over the two operating systems. That is Windows operating system and our Linux operating system. So we want you to write assembly on both of these different operating systems. Now, the reason we do that is because assembly can differ slightly for each operating system, but also each compiler that you use, assembler that you use. And this is important for you to identify later on when you're reverse engineering. So that's the reason why we decided that the first few episodes, we want you to actually start writing assembly language. Now, we haven't just split it up into like the operating systems, we've also done architectures. So you'll see when I go to demo some of the labs, you'll see that we've got Linux 32-bit operating system, Linux 64-bit operating system, then you've got Windows 32-bit operating system, and Windows 64-bit. Now, the reason we've also done that is because we want you to identify what the differences are when writing assembly language for 32-bit architectures as well as 64-bit architectures. And this is something that is incredibly important when you're coming across different binaries such as 64-bit or 32-bit, because it sometimes changes the way that you approach analysis of these. I mean, not only does it mean that you're probably going to be using different tools, but there are different ways that the 64-bit operating architecture interacts with the stack, for example, compared to the 32-bit. And these are all things that are explained in these different series of labs. And then we finally move into the introduction to reverse engineering. So you'll grab it's probably my favorite disassembler, which is Ghidra. I would probably say it's my favorite due to the fact that it's free. Obviously there are other big disassemblers such as IDA Pro. Now, for everyone who's not aware of what a disassembler is, it takes our binary, our machine code, and basically translates it back into assembly to its best of its ability. There are techniques used by malware authors in order to obfuscate that, so it's difficult to get the assembly back to its original source code format, but we will also be teaching how they do that so that you can start to understand these aspects as well. But at the beginning, we'll be showing you how to analyze binaries for each operating system again, so Windows and Linux, as well as the two architectures for both operating systems as well. So we're really trying to give you a good spread of understanding over these different architectures that you'll be seeing every day in your job. Awesome. So over to the demo. So for everyone who's not seen Immersive Labs before, when you sign up and get access to the platform, you'll have your own dashboard. So you can see here, this is me and McCarthy. This is the labs, the amount of labs I've completed. This is the amount of points. I'm sure there's many people on this call that have got a lot more points than me. So if that is the case, then I'm very happy for you. Then if we go to the browse section, this is where you see all of our labs. So we do have over 1,000 labs on the platform, and they range in all different aspects of cybersecurity. As you can see here, we've got the different categories, so fundamentals, offensive, defensive, our threat intelligence section that I discussed earlier about how we release labs within 24 hours, malware reverse engineering, which is the bit that we're going to be talking about very soon, down to application security and cloud security. So like a huge catalog of different labs which really take you through all aspects of cybersecurity. Now, one of the things I wanted to discuss here is you can see here we've got lab series and lab skill path. Now, lab series is effectively just a set of labs where at the end of it you will gain a badge for completing those sets of labs. If it's a skill path, you have a demonstrate lab attached to this. So you have a bunch of these labs. So this is encoding and encryption. You can see all of the labs here, binary, hexadecimal, and then you have your demonstrate lab as well. And this will give you, one of these demonstrate badges to say you have completed this skill path related to encoding and encryption. So it's a really nice way to kind of give a bit of motivation to completing these different series. And it's a really nice way for us to break up the different content that we have on the platform as well. But if we go to my favorite section of the platform, malware and reverse engineering, you can see these 3 series that I've just talked about. So computer architecture, assembly language, and introduction to reverse engineering. Later on, we will be releasing sort of intermediate levels and advanced levels as well. My plan for the next sort of section of this is to release a bunch of labs on the tools that you'll be using. So disassemblers, debuggers for the dynamic code analysis, tracing tools, for example. And then when we go down the specific malware analysis route or the binary exploitation route, we'll be looking at specific tools for that as well. So if we go into computer architecture, for example, you can see we've got a bunch of different labs. So introduction to 30-bit architecture, 64-bit architecture, Linux internals, for example, the inside of a PE file. Now, what I was saying earlier about PE and ELF, PE is that native portable executable that's run on a Windows operating system. So let's go in and have a look at the lab. So when you go to a sort of labs landing page, you'll get the learning outcome. So what should you expect to get once you have completed this lab, and also what is actually involved inside this lab. These are all sort of our theory-based labs. So these are and what we mean by that is they are gamed labs. So we give you a bit of information on the side, and then we ask you to either answer a quiz or answer a bunch of questions related to the info section. Also, as you can see here, we've got Pioneer. Now we've just released this lab series, and so what that does is that gives everyone basically the opportunity to go and be the pioneer for their organization on these new labs. So what this means is the first person inside your organization to complete this lab will forever be crowned the pioneer of this lab. So I do implore you to go and kind of get as many pioneer badges for the reverse engineering series as possible. If you do that, you can add me on LinkedIn and then share the screenshot of all the pioneer badges that you've got for the reverse engineering, which would be very cool to see. So we start the lab. Now, for anyone who's not seen Immersive Labs before, this is like I said before, this is our sort of gamified theory labs, and I will take you through our practical labs very shortly. But on the side here, we've got all the information needed to go and complete the lab. So this is an example of one of our coach labs. You know, it gives you what introduction to portable executable, for example, some nice graphics, and then we go into a breakdown at a level that a reverse engineer needs to know, right? So this isn't while this is an introduction to reverse engineering, there is still like assumed knowledge that you need to know. So you need to understand a little bit about Windows. What is Windows? How to use the command line and those sort of aspects before coming on and doing these different labs. So you can see we've got the graphic here, so the MS-DOS header. There's a bunch of different aspects to the portable executable file, and then we go into depth about which each aspect of the portable executable file. So but what I've done here is I've actually specifically mentioned the bits that are important for binary exploitation and for malware analysis. So you can see here a few really important ones for malware reverse engineering exploit development are the import, resource, and export. You know, there's a bunch of different other directory entries inside a portable executable file which are used, but are not don't necessarily give you as much information as you need. Whereas if you go to the import, the resource, and the export, you'll find a lot of very useful information for you there. And then once you've completed that, you can start answering the questions. So the time date stamp within the P header file counts from which following dates, and all of this information, you know, is actually inside the info section. So let's go on to something a little bit more fun. Let's go to reverse engineering, of course, and let's have a look at the assembly language. Now, at the moment, we've released 2 episodes for each 32-bit, 64-bit for Windows and Linux. And if we click on one of these, for example, 32-bit Linux assembly, they're all kind of following the same sort of format. So the first episode in each of these operating system and architecture labs asks you to do the same thing. Now, the reason we're asking you to perform the same activity is because we want you to understand what is the difference between printing I love assembly to the screen in the 32-bit Linux. How does that differ to the 64-bit Linux? And how does that differ to the Windows 32-bit? And how does that differ to the 64-bit Windows as well? So, you know, these different aspects are really important for you to understand when you're going to you know, progress and start analyzing different pieces of malware and binaries for binary exploitation. So we take you through a little bit of an introduction, and as you can see here, we talk mainly about structures and registers. So when we say structure, you know, there are different structures inside an assembly file that we need to be thinking of. That is the structure of how to create an instruction, as well as the structure of an actual program. So we take you through examples of how to use the mov instruction in assembly, for example. Then we go down into the program structure. So inside these 32-bit Linux files, what do you need to have in order to create a assembly file which will be eventually assembled into a binary? So if I go to ls here, for example, you can see we have assembly.asm, which is our assembly file. So if I just cat that at the beginning, you can see we've got an incomplete assembly file for you to go and actually go and complete. So you can see here we've got the sort of generic structure, the sort of skeleton of the assembly file has been created for you, but you need to go and actually complete each of the ones that say task here. So declare the .text section, and that was the thing that I was on at the moment. There is the .text section is used to store all the executable code the program will run. The entry point will be somewhere inside this section and flagged. So, you know, the point is that we want to give you information around why you're learning something, but also give you the practical exercise to start messing around with these with assembly. Now, this Linux machine, as you saw, took about 8 seconds to load, and this is a completely sandboxed environment for you to start messing around with. If you know, you're not going to be able to start pinging the internet. You're not going to be able to start attacking other people's boxes with this Linux machine. This is completely bespoke for you to mess around in, and then once you've completed the lab, you can you'll gain a little token, which you'll put into the task section here, and then it will complete and you will get your points for completing the lab. And like I said, if we go back to the assembly language, you can see we've got episode 1 and 2 of 32-bit Linux, Windows, 64-bit Linux and Windows as well. And finally, the last aspect of the platform is the introduction to reverse engineering. So this is where we take the binaries that you have actually created in the assembly language series. So, you know, for example, the I love assembly printed to the screen. The second one was messing around with structs inside the binaries, because you know a lot of Windows is basically just structs. And what you do is you actually go and use Ghidra, the disassembler released by the NSA, to reverse engineer these binaries to understand what we want you to look at is, right, this is how you implement the source code. And then when you're reverse engineering, what is it about the source code that is kept for the binary to actually run effectively and do what you want it to do? So that's what we're trying to do, is trying to get you to marry these two things up in your head, because then it becomes a lot easier to start hypothesizing why things are why malware is running a certain way, because you would have messed around with some source code of binaries before. So if we go into 32-bit Linux reversing, for example, again, this is a Linux environment, takes 8 seconds to load. It's your own sandboxed environment. You know, no one's going to, this isn't a shared instance. No one is going to jump on there with you and start messing around with it. And you can see here we've got Ghidra, my favorite tool, very close to my heart. But what these labs are describing is the process of identifying that this is a 32-bit Linux binary to analyze, and then also the tools needed to start identifying that. So, for example, really, like this is episode 1, so we're looking right at the basics of the file command, and then the readelf command. These are two important tools that you can use to identify what a binary is. And once you've identified, right, this is a Linux binary and this is 32-bit, then you can identify which tools you need to use and which process you need to go through in order to start analyzing that specific binary. So you can see here readelf, and then eventually we get into Ghidra, like I said, my favorite tool ever, actually, ever. And we, in the info section, we give you different things, different parts of the tool to start looking at. So program trees, symbol trees, sort of comparisons of the code, for example. You can see here we've got, this is what the source code looked like, and this is what the Ghidra disassembled code looks like, for example. And this sort of information is really important to understand early on when you're beginning your reverse engineering career, because later on in the next iteration of the series, you're not going to be, we're not going to give you the source code. You're not going to be writing the source code. You are going to be actually just given the binaries to start analyzing. So there we go. Just need to go and compile the binary first. So if you go to the task section, this tells you a little bit about what you need to be doing. So you'll be going through the actual reverse engineering process. So assemble and link the assembly program using NASM. So let's go here, NASM L32 assembly ASM, and assembly.o, and there you go. So we just assembled the program. You can see here it is now called a.out. So firstly, what it's asking you to do is analyze a.out using the file. So let's just start doing that. So we've got the file. You can see here it's an ELF executable. You would have understood what an ELF executable is based on the what is ELF executable lab that we did earlier on in the computer architecture series. You can see that it's 32-bit and that it's statically linked and not stripped. Now, all of this sort of information is actually identified in the info section, and you are told kind of what these different aspects mean and which parts are actually important for you to understand for analysis, basically. And once you've moved on from the file, we can start doing the readelf as well. Let's do that. You got it needs a switch as well. So you can see here we've got use readelf. What is the entry point address for the a.out executable? You can see the entry point address is here. So this is actually the default entry point address for the assembler that we used. And so these sort of little hints and sort of tricks you will learn throughout this series, of things that you'll commonly find. So the beginning, the entry point is quite commonly this 8048 80 address, for example. And I'm not going to ruin the rest of the lab because you need to go in and actually complete it. So again, you will be using Ghidra to start understanding and moving around that tool, because it can be quite a complex tool. But the idea is that we want to introduce these tools alongside the reverse engineering process, so you have an understanding right from the beginning. So you can see here, Ghidra, how to actually open up a project, and then where to go to start analyzing different aspects of the binary. Awesome. So that concludes it. The kind of I think that's enough time. So do we have any questions? This is sort of the Q&A aspect of the presentation.
Thanks, Ben. Yes, we actually do have a few questions that have come in. So first one, could we just get a reminder of the names of the free disassemblers again?
The free one, yeah. So you can have, so Ghidra is the one that you'll be using in this series. It's become pretty de facto now. I know a few sort of very good reverse engineers who have stopped paying for IDA Pro in order to use Ghidra solely, because it also comes with a decompiler, which I didn't mention here, but we go into that later on in the series. The other is you can actually download IDA Pro free version as well and use that. So I would say that those are probably your two go-to free disassemblers. There is another fun one called Radari too, and we do actually have a bunch of labs on the platform that showcase that tool as well. But that's I would say that's more often used for crack me binaries and sort of CTF challenges than sort of production professional disassembly, for example.
Okay, perfect. Next one, will you monitor for dead ends where people are stuck and few people get an answer?
Yes. So I suppose one of the things I would say is that if you feel like that is the case, you can always just message support to say we feel like this isn't explained particularly correctly, or could we have a bit more clarification? And then what that will do is that will come back to the content team as a user suggestion, and we'll have a look at it and see if and we'll start identifying how many people have been stuck and make a decision from that aspect. But I like to hear feedback on labs. So if you want to put user suggestions or say that you really like the lab, hopefully. But if you don't like the lab, put a support ticket through, and we're happy to have a look at it.
Okay. Are labs free for exercise?
So we do actually have a community edition, which I was going to go on to here. So you can join our community mode, so community.immersivelabs.online, where you can, you won't have all labs, because like I said, we have 1,000 labs currently. You won't have all labs on the community mode, but you can start to see kind of the benefits of Immersive Labs and how we spin up Windows machines, how we spin up Linux machines, and you can really start to play with the tech stack that we have. So I would recommend signing up for that and having a mess around with some of those labs there. I think we actually released our threat intel driven sunburst lab series there. So that's 4 or 5 labs on the Sunburst malware attack that happened recently.
Okay.
Go and have a little look.
Why would you do static code analysis?
Why would you do static code analysis? So a lot of the times, well, I mean, it's safer, firstly, to do, because you're not actually running any code. So, inherently it is a little bit safer. So I would say that's probably the biggest reason as to why you would do static code analysis. Admittedly, it does normally take longer than dynamic analysis, where you're actually running the code and kind of following it along with a debugger. But a lot of malware authors will do debugging protections. So they'll implement code inside their binaries which stop you from being able to debug and like run the code and analyze it that way. So at that point, you'll probably have to open up a static code analyzer to understand what's going on from that. And that's just one example of one of the reasons why you would analyze something statically.
Perfect. So I have 2 Pioneer related questions here. The first one is, can you opt out of Pioneer? And then the second one is, how do we view our Pioneer badges?
So at the moment, I don't think you can opt out of the Pioneer badges. So the first person to complete the lab in your organization will get the Pioneer badge. But one of the reasons we also did that was to kind of give people visibility over who in their team has completed it. So if they get stuck, they can actually go and ask questions to that person. So we kind of see it as like a benefit for our customers. And secondly, with the Pioneer badges, that's something that we can report on in the back end, but it's not something that a normal user who's not sort of a manager can see yet.
Okay, great. Hopefully I pronounce this correct. Are you going to do ARM assembly, or is that ARM assembly?
ARM assembly, yes. So no, it's a really good question. So as you can probably, as I said, probably too much. We've got 32-bit, 64-bit Windows and Linux. We're also going to be doing the same thing for ARM as well. But at the moment, the priority was a sort of x86 family architecture. So but yes, that is on the roadmap to come.
Okay, great. And just a reminder to everybody, if we're unable to get to all the questions today, we will follow up after the webinar through email. Can Ghidra work on APKs? Is that correct?
APKs, I believe. I don't believe it can. I've never actually used it for that. So there's a different sort of reverse engineering process used for APKs. So for anyone who doesn't know what an APK is, it's the file format for a Android application. So there's different reverse engineering process. So you would typically unzip it and then open it up into something like JD GUI, for example, so you can start viewing the sort of Java source code, for example. So I don't think that you can with Ghidra, but yeah, I haven't used it for that. If you can, but I'm pretty sure you can't.
Okay. What will be included in the intermediate static code analysis series? Will there be different tools available?
Brilliant. Yeah. So great question. So yes, we are going to be releasing labs. So I want to go quite in depth into the different aspects of what Ghidra can do. So like using automated. So you can use Java or Python to basically automate processes in Ghidra. So I want to go into depth with sort of an episodic series on Ghidra. For example, Windows debug. So you can start analyzing user mode and kernel mode sort of applications. Then sort of x64 debug as well, because it's a very popular debugger. Then GDB for your binary exploitation on Linux. And then I want to go into sort of tracing tools as well. So to understand kind of how to implement your own tracing tools, because sometimes, you know, out the box debuggers just don't quite cut it. So yeah, there's so those are the things that you should be expecting in the intermediate section, and then we will start going down into individual pathways of malware analysis and binary exploitation, kind of going over the different techniques of, you know, how do malware authors evade detection, how can you analyze that, and then from a binary exploitation perspective, you know, how does stuff like ASLR affect what you're doing with like when you're trying to massage memory, for example. So it's you know, super interesting. I'm really excited for the next stages of this series.
Okay, perfect. Let me just go through some of these. Is there going to be an analysis of mobile devices?
Yes, there will be. That's something that I've you know, been kind of thinking about in my head quite a lot recently. So the answer is yes. I definitely want to go through the reverse engineer process as explicitly as I have with the x86 and the x64, with sort of mobile applications as well. In terms of sort of time on that, I'm not 100% sure, but yeah, that is on our roadmap.
Okay, great. I do have another roadmap type question. Would you cover the dynamic analysis in the future as to see the stuff happening in real time?
Yes, yeah. So you know, this was an introduction to sort of static code analysis, like I was saying. But in the next stage, I'm going to start kind of incorporating a bit more dynamic analysis. So, you know, your different debuggers like WinDebug for Windows, x64 debug, GDB for your Linux. Yeah, because I mean, the best reverse engineers use both static and dynamic analysis. So you need to be proficient in both. So we're definitely gonna do series on those sort of tools as well.
Okay, great. So it looks like we have time for just about one more question. And again, we'll follow up after the webinar if we're unable to get to you. But last one here, are there any issues analyzing a binaries for one platform on another platform, i.e. analyzing an ELF file from a Windows machine?
Oh, so really good question. So there will be issues if you are doing dynamic analysis. You know, so if you're, for example, you can't natively run an ELF executable on Windows unless you go to the Windows subsystem, you know, that sort of thing. But then again, you're using Linux really for that. The Linux Windows subsystem, sorry, WSL. But in terms of static code analysis, you can do that on either operating systems for both binaries. So for every single reverse engineering episode, you're on the normal Ubuntu desktop with Ghidra, and you'll be analyzing ELF and PE executables. But again, if you're doing dynamic analysis with debuggers and stuff, you're you know, it's worth just going onto that actual operating system to do that analysis.
Okay, great. Well, that's it for the questions for now. Thanks, Ben. This was a great presentation.
Thank you, everyone. And I hope you have a great rest of your day.